Forget everything you think you know about North Korea's military capabilities, the regime that Western analysts have spent 30 years dismissing as a backward, isolated, economically broken state run by an eccentric dynasty, has just demonstrated a weapons capability that no NATO member possesses in operational deployment, a capability that could reduce South Korea to pre-industrial darkness in minutes, and against which the combined military power of the United States and its Pacific allies has no reliable defense. What happened in the Yellow Sea testing corridor was not a missile test, it was not a nuclear demonstration. It was something far more strategically significant, and the fact that you are hearing almost nothing coherent about it from mainstream sources tells you everything about how thoroughly the people who are supposed to protect you have failed to understand what Kim Jong-un has been building. North Korea tested an electromagnetic pulse weapon. Not a theoretical device, not a laboratory prototype, an operational weapon delivered by ballistic missile that generated an electromagnetic pulse of sufficient magnitude that monitoring stations across South Korea, Japan, and American facilities on Okinawa registered anomalous readings consistent with high-altitude nuclear or non-nuclear EMP detonation. South Korean infrastructure in the affected monitoring zones experienced transient disruptions. The South Korean government's official response was carefully worded to avoid confirmation. That careful wording is itself confirmation for anyone who understands how these events are managed. Having spent years in military intelligence, having sat in rooms where men discussed North Korean capabilities with a seriousness that never reached public discourse, I can tell you without hesitation that this test changes the threat calculus on the Korean Peninsula in ways that American strategic planners are not prepared to explain to the public. Stay with me because the technical dimensions of what North Korea has achieved need to be understood before we can grasp the full strategic weight of what just happened. An electromagnetic pulse weapon exploits a physical phenomenon that has been understood since atmospheric nuclear testing in the early 1960s. The Starfish Prime test conducted by the United States in 1962, a 1.4 megaton nuclear detonation at an altitude of approximately 400 kilometers above Johnston Atoll in the Pacific, caused electrical failures across Hawaii, nearly 1,400 kilometers away. Streetlights failed. Burglar alarms triggered. Radio communications disrupted, and that was the unintended consequence of a nuclear test, not a weapon optimized for electromagnetic pulse effect. Modern understanding of EMP physics, developed through decades of classified and declassified research, identifies three distinct pulse components designated E1, E2, and E3, each affecting different categories of electrical and electronic systems. The E1 component, generated in the first nanoseconds of a high-altitude nuclear detonation, produces an extremely fast, high-intensity pulse capable of destroying solid-state electronics, the microprocessors, communication chips, and control systems that every modern military and civilian system depends on. The E2 component follows milliseconds later, similar in character to a lightning strike, but affecting systems that have already been damaged or rendered vulnerable by E1. The E3 component arrives later still, lasting seconds to minutes, generating geomagnetic disturbance effects that induce powerful currents in long conductors, power transmission lines, pipelines, railway tracks, capable of destroying transformers and power distribution infrastructure. The critical point that most analysis ignores is that effective EMP effect does not require nuclear detonation. North Korea's test appears to have employed what weapons physicists designate as a non-nuclear electromagnetic pulse device, specifically a flux compression generator or magnetohydrodynamic explosive munition system capable of generating extremely high electromagnetic field intensities without nuclear warhead employment. The advantage of non-nuclear EMP is decisive for operational use. It eliminates the political, diplomatic, and escalatory threshold associated with nuclear weapons employment while delivering comparable electronic warfare effects against unshielded infrastructure. North Korea can use this weapon without triggering the nuclear response threshold that has constrained its military options since it achieved nuclear capability. What I have not yet explained is the specific vulnerability profile of South Korean and American military infrastructure in the Peninsula Theater, and this is where the assessment becomes genuinely alarming. South Korea operates one of the most technologically advanced economies and militaries in the world. That technological sophistication, which represents South Korea's greatest conventional military strength, simultaneously represents its greatest electromagnetic vulnerability. Modern fighter aircraft, the F-35 Joint Strike Fighters that South Korea operates, the F-16 variants, the domestically developed F-A-50 light combat aircraft, are critically dependent on sophisticated avionics, fly-by-wire flight control systems, and digital communications architecture. These systems were hardened against radar jamming and conventional electronic warfare. They were not hardened against the field intensities that a properly positioned EMP weapon generates. Multiple assessments conducted by independent electromagnetic compatibility researchers working from publicly available military procurement specifications conclude that the majority of aircraft currently based at South Korean airfields would experience avionics degradation or failure under EMP field intensities consistent with what North Korea appears to have tested. The ground situation is equally concerning. South Korean mechanized units rely on digital command and control networks, GPS-guided artillery, digital fire control systems in armored vehicles, and sophisticated logistics management software. American forces stationed in South Korea, approximately 28,500 personnel operating from installations including Camp Humphreys, the largest overseas American military base in the world, located approximately 90 kilometers south of Seoul, depend on the same technological infrastructure. Camp Humphreys alone hosts hundreds of vehicles with digitally controlled systems, aviation assets, and communication facilities. The base was constructed with extraordinary expense and sophistication precisely to serve as the command hub for Peninsula defense. A successful high-altitude EMP detonation positioned over the peninsula would not merely inconvenience American and South Korean forces. It would systematically degrade the digital nervous system on which their operational effectiveness depends. Before we go any further, I need you to understand the delivery problem, or rather, why North Korea does not have a delivery problem. The Hwasong-17 intercontinental ballistic missile, which North Korea has tested multiple times with confirmed success, can loft a payload to altitudes exceeding 6,000 kilometers when fired on a high-trajectory lofted profile. A nuclear warhead, or non-nuclear EMP device, detonated at 100 to 300 kilometers altitude over the Korean peninsula, would generate electromagnetic effects across the entire peninsula and potentially affecting Japan. North Korea does not need an EMP device on an ICBM. For peninsula range employment, the Hwasong-11 series short-range ballistic missiles, the Hwasong-12 intermediate-range missile, or any of the solid-fueled ballistic missiles North Korea has demonstrated provide more than adequate altitude and range for optimal EMP positioning over South Korean territory. The delivery problem was solved years ago. What has now been confirmed is that the payload has matured to match the delivery capability. The mainstream media will not tell you what this means for the conventional military balance that American extended deterrence has depended on since the Korean armistice. I will. American military strategy in the Pacific, specifically on the Korean Peninsula, has always rested on the assumption that American technological superiority in conventional military systems provides a decisive advantage over North Korean forces that are numerically large, but technologically generations behind. The kill chain concept, officially designated as Korea Massive Punishment and Retaliation, depends on American and South Korean forces identifying North Korean missile launch preparations and striking before missiles can be fired. This requires functional intelligence, surveillance, and reconnaissance systems. It requires functional communications between command authorities and strike aircraft. It requires functional aircraft with functional avionics. An EMP attack in the opening minutes of a conflict before South Korean and American forces can execute the kill chain sequence degrades every capability that strategy depends on. North Korea understands this. The EMP test was not simply a weapons demonstration, it was a strategic communication Kim Jong-un was showing to South Korea, to Japan, to the United States, that his military possesses the ability to degrade the technological foundation of Allied defense before the alliance can execute its offensive strike plans. That is not a tactical development. That is a fundamental shift in the strategic balance of the peninsula. Stay with me because what I am about to tell you about the civil infrastructure dimension makes the military picture look manageable by comparison. South Korea's civilian electrical grid was not designed with EMP hardening. No civilian electrical grid in the world was, because the cost of hardening transmission infrastructure against high-intensity electromagnetic fields is extraordinary. Estimates for hardening the American electrical grid alone range from $2 to $4 trillion, and governments have consistently prioritized other expenditures. South Korean transmission infrastructure, including the high-voltage transformers that serve as the critical nodes of the grid, represents exactly the type of equipment most vulnerable to the E3 component of an EMP event. The large power transformers that regulate voltage across South Korea's national grid are custom manufactured, require lead times of 12 to 18 months for replacement, and have no significant spare inventory. A successful EMP attack that destroys a substantial portion of South Korea's transformer infrastructure would produce power outages lasting not hours or days, but months to years. The cascading consequences of extended power grid failure in a modern industrial economy are difficult to overstate. Water treatment and distribution systems fail within hours. Hospital backup power lasts days. Food refrigeration and distribution collapses. Communications infrastructure dependent on powered base stations and data centers goes dark. Financial systems cease function. Fuel distribution becomes impossible without functioning electronic payment and logistics systems. The South Korean economy, the 12th largest in the world, one of the most export-dependent and technologically integrated economies on Earth, has an extraordinarily high vulnerability to exactly this scenario. You think you have heard the worst of it. You have not. The escalation dynamics created by North Korea's EMP capability are profoundly destabilizing in ways that crisis management theory has not adequately addressed. Consider the decision sequence that South Korean and American commanders face if they receive intelligence suggesting North Korean forces are preparing for military action. Their response options include preemptive strikes against North Korean missile systems, the kill chain. But any detectable preparation for those preemptive strikes gives North Korea the incentive to use its EMP capability before Allied strikes can reach their targets. The decision calculus therefore creates pressure toward escalation on both sides simultaneously. North Korea's incentive to use EMP before being struck and Allied incentive to strike before North Korea can use EMP create what strategic theorists call a reciprocal fear of surprise attack, a crisis dynamic historically associated with the most dangerous pre-conflict periods. The regional implications extend beyond the peninsula, with implications that Japan is beginning to process with appropriate alarm. Japanese infrastructure faces the same EMP vulnerability as South Korean systems. American facilities at Kadena Air Base in Okinawa, Misawa Air Base in northern Japan, Yokota Air Base outside Tokyo. All of these installations fall within the effective range of North Korean ballistic missiles and would be affected by a high-altitude EMP detonation positioned for peninsula effect. Japan's self-defense forces have begun accelerating EMP hardening programs, but the timeline for meaningful infrastructure protection is measured in years, not months. The decisions being made right now in Washington, Seoul, and Tokyo about how to respond to this confirmed capability shift will determine the strategic architecture of Northeast Asia for the next decade. The options are unpalatable. Negotiation with North Korea over EMP capability faces the same fundamental obstacle as every previous negotiation effort. Kim Jong-un has no rational incentive to surrender a capability that provides strategic deterrence against a conventionally superior adversary. Military options for destroying North Korean EMP capability face the same underground hardening challenges that complicate targeting of nuclear facilities. And the passage of time without a solution means that North Korean EMP capability will mature, will be integrated into operational doctrine, and will become an assumed feature of any peninsula conflict scenario. I have watched this pattern play out for decades. A capability emerges that fundamentally alters a strategic balance. Official voices minimize or deny. Independent analysts sound warnings that are dismissed as alarmist. And then the capability is used or its existence forces strategic accommodation in ways that could have been addressed earlier had the warnings been heeded. We are at that moment now with North Korea's EMP program. The next 72 hours, the next several weeks of diplomatic and intelligence activity will begin to reveal whether Western governments are prepared to engage this reality honestly, or whether they will continue the comfortable fiction that North Korea remains a containable, manageable problem. The clock is running, and the lights may not stay on.